Efficiently finding the minimum sum of absolute differences in array pairs. The problem, minimizing sum of absolute differences in pairs. Given an array, the goal is to pair its elements and minimize the sum of absolute differences between pairs. For example, 4, 1, 2, 3 pairs 1, 2, and 3, 4 give sum 1-2 plus 3-4 equals 2. 1, 3, 3, 4, 5 pairs 3, 3, and 4, 5, ignoring one element, result in sum equals 1. This problem is straightforward when the array length is even. Simply sort the array and pair adjacent elements. But when the array length is odd, one element must be left out, complicating the minimization. Naive approach and its drawbacks. A brute force method removes each element individually, to get an even length array, then applies the adjacent pairing method to find the minimum sum. This gives even length arrays, pair adjacent sorted elements. Odd length arrays, try removing each element and compute the sum each time. Problem, this approach is O and 2 due to repeated sorting or slicing, making it inefficient for large arrays. Efficient solution, leveraging sorted array and prefix computation. Key insight. Sorting the array lets us pair adjacent elements to minimize differences. When the array length is odd, leaving out each element affects only pairs around it. Instead of recomputing sums for each removal, compute once and then update incrementally. Sort array, A equals A1, A2, n. For even-sized array after removal, the minimal pairing sum is \sum A underscore 2i A underscore 2i1. Pattern when removing elements. Consider removing each element from a sorted array. The difference sums change slightly from one removal to the next, so calculate the sum for removing the first element. For each subsequent element to remove, adjust the sum by adding and subtracting only the values associated with the elements entering/exiting pairs. Algorithm steps. Sort the array. Precompute the list of differences between adjacent elements. Calculate the initial sum of paired differences by pairing adjacent elements, for even length. Use prefix sums or a similar technique to update minimal sums efficiently for each possible removed element. This reduces the overall complexity to O, n log n, dominated by sorting, with the sum calculations done in O, n. Example Python implementation outline. For full implementation, carefully handle index changes and pair adjustments. Summary. Sort the array to minimize pair differences. For even length arrays, pair adjacent elements directly. For odd length arrays, instead of expensive full recomputations, incrementally update the sum when removing each element, leveraging the structure of sorted pairs. This approach yields a much faster solution suited for large datasets. By exploiting array sorting and partial sum reuse, you can efficiently compute the minimal sum of absolute differences for pairing elements in both even and odd length arrays.